Afternoon, everybody. How we doing? Hopefully I'm on time. Probably a bit late. Maybe a couple minutes late. I don't know. Bit of a rush again, but there you are. How are we all doing today then? It's not bad weather today. Bit blowy, but a bit of sunshine, bit of cloud. You know, all good. So we got Jay in first. Well done, Jay, and welcome, mate. Anthony Carter. Hi, Anthony. And Brett. Glorious sunshine. Wow. Auntie said he had rain in East London this morning, but brightened up a bit now. I think we had a bit of drizzle earlier, but I think it's mainly been wind today. Michael Hyde. Hi, Michael. Phil Taylor. Hi, Phil. Multi. Hi, Multi. And Les. Hi, Les. How are you, mate? This is Les's kit, actually. Les let me have this, so thank you very much, Les, for this. I'm sure this is going to be fun trying to build this. I say trying because you never know what's going to happen, do you? Everything seems to go wrong that can go wrong. So, Pat Jones, hi Pat. Rob Tiveridge, hi Rob. Cyberflyer, hi Cyber. I think I said hello to Brett, didn't I? Yeah, Brett. David Tag. That's Harvey. How did you get? I don't know, mate. You must be beamed up. You must be being beamed up by somebody or other. Aston, how you doing, mate? Hope that phone's sorted, mate. Sounds like you had fun and games with that. So yeah, today we've got an AM transmitter kit to build, which is quite interesting. It's all too easy, isn't it, to just go and buy one of these things, but to have it in a kit form is even better, I think. So anyway, oh, hello. I'm trying to get the instructions in shot here, but I've got problems with me camera set up. So let's go in a little bit and we'll have a look at the front page of the instruction book, because there's nothing really to see yet because it's not built. Let's have a look then. There's a bit of glare on that as usual. That's a bit better. So we were talking about these kits the other week, weren't we? Not kits, but we were talking about transmitters. So I'm just trying to sort the light out. Oh, it's a blimmin' light's a pain in the neck in here. Maybe I'll just get rid of that one altogether. That's better. There we are. It's better without the bench light on, believe it or not. So let's set a cube onto that. This is what we're going to be building today. Low power AM broadcast radio transmitter kit. It's a bit of a mouthful, isn't it? Looking at the date on this, it's actually March 2015. Let me just go in a little bit closer so you can see a bit more detail. So I believe this is American. But these are supposed to be very good. So fingers crossed it's going to be the business when we build it. Yeah, Les says excellent. Les has actually got one of these already, so this was a spare one that he managed to find in his mum's loft. So brilliant. And as I say, I've got the Spitfire transmitter, but that came ready built, although it does need a little bit of tweaking once you've got one of those. You need to get inside the thing really and have a bit of a play around. Afternoon, Floppy, how are you? And hi, Luigi. So yes, that's what we're going to be building today. Whether we'll get it done or not, I don't know. There's quite a lot of parts to it. Let's flip the page and have a look, see what else it says. Getting organised. Yeah, we're never organised. Bits and pieces. Massive great parts list as per usual. It's very nice actually. I'll show you some of the bits in a minute. You'll have seen it on the cover shot today, but all the chokes and that are already there. I don't think we've got to wind any coils. Circuit board locations, bit of soldering advice there. How to do the solder and how to put the pieces in, components even. And then it goes into assembly. Massive great list of resistors in here, absolutely dozens of the things. dip switches, rear panel jacks, ICs. Yeah, it's a fairly substantial kit there. So it looks like we've got a voltage regulator and heat sink as well, 15-volt regulator. Power on check. There's an AC adapter. Plug the AC adapter cord into the power jack. Have we got an AC? Not sure what the power supply situation is on this thing. It says AC power supply. There is no power supply with it, which is interesting. It says, congratulations, your board is now fully assembled on this side, look. I don't think so. Yeah, congratulations, your board is now fully assembled. So let's go on to the main camera. So I'm just having a quick look through. Let's have a look back at the parts list then. Yeah, we should have an 18-volt AC 500 milliamp 2.1 mil FAC adapter, which we haven't got. 18 volts AC at 500 milliamps. That could be an issue. I've certainly got an 18-volt transformer here, but I'd need to build a power supply for it, so that could put the kibosh on it today. Yeah, I don't remember seeing an AC adapter. We've certainly got the enclosure, but yeah, no, there's no AC adapter. So whether that's an optional extra, I don't know, but the box wasn't big enough to have an AC adapter in it. That's Mrs. Cruncher with the hairdryer now. Okay, so we failed at the first hurdle, really. Oh dear. Power jack 2.1 mil. I mean, can I feed it with DC? I don't suppose it would hurt feeding it with DC, would it? I mean, let's go back to the thing. If you look at the bottom one there, look, that's the AC adapter. So that purely is a transformer by the looks of it. 500 milliamp, 18 volt, and then you've got a 15 volt regulator in the thing to drop it back down to 15 volts. Yeah, we might be able to get something cobbled up. Can't remember what that power supply was last week that we were looking at. Anyway, looks like we haven't got that. Les is saying no PSU. Yeah, Anthony's saying use a laptop power supply. Les runs an 18 volt computer PSU on the 12 volt reg. 18 volt computer PSU. Okay, I've probably got a laptop power supply knocking about that we can try. If not, we do have various transformers here. So I'm sure we can work something out, hopefully. Yeah, if it has a bridge rectifier, you can feed it DC. Let's have a look then. Has it got a bridge rectifier? Integrated circuits, diodes, transistors, voltage regulator. Yeah, it's got 4 1N4002s, Rob. Silicon rectifiers. So I assume that's for building a bridge. Let's have a look in the manual a little bit further a minute. Doesn't really I don't know if it tells you that rectifiers and diodes. Yeah, it's pretty much almost like a paint by numbers. So on the actual board itself, just here, we should have D1 to D4, which is going to be our bridge rectifier. Now, where's that going to be? D5, D6. It's nice that they put the surface mount component on the board already, look. It's nice of them. Ah, here we go. D1, D2, D3 and D4, look. Just there. Sure you can see that. That's quite a nice board as well. Double-sided. I think it's got traces. Yeah, it is a true double-sided board, so there's traces on both sides. Alright, so yeah, we can, as Rob is saying, feed it with DC. Not a switch mode. No, I'll just feed it with my bench supply, or I can cobble up a transformer. What have we got here? See, we've got a power supply. We've got a transformer here. I can't remember what the secondary is on this. What's this? This is yeah, this gives 24 volts out on the secondary. Probably a bit over the top, isn't it? Maybe a bit overkill. And really we want the 18 volt one, which I think is here. Is this 18 volt? 16 volt. I have got an 18 volt one somewhere here. But yeah, so I mean we've got 24 volts. I don't know what the maximum rating of that, what am I trying to say? The maximum rating of the regulator is. That's what I was trying to say. Any 18 volt supply. Like I say, I have got a computer power supply. Let me just see if I've got an 18 volt laptop supply, because that would sort it right out, wouldn't it? AC adapter 4.5, no, DC. What's this one here? Bose output DC. That's DC. That's a switch mode. Trying to think where my laptop is now. I think it's in the wardrobe, my laptop. Anyway, we'll leave that for a minute. Be messing about for hours here and we'll never get anything done else. But if we can feed it with DC, then that'll be fine, won't it? Certainly can feed it with the power supply. So I've got my cup of tea here at the moment, so let's have my cup of tea. Yeah, I've got a variable output on that board though, Les, so I can drop it back down. Just saying that's DC. I've just found my shaver socket. I knew I had another one of those somewhere. Ideal. Right, so that's the board. So let's get it underway. I've got my board holder, so we'll use that. from Mr. Andrew Alsfer. I don't know if Andrew's with us today or whether he snuck off to the NVCF or Retrotech as it's called. But yeah, this was a present from Andrew, which is a great bit of kit. It's basic, but it does the job. In fact, this is going to be on maximum width, I think. Let's mount it that way. No, it's better to mount it that way by the looks of it. So if we mount the board in this holder, it just makes it a lot easier. I've got my blue mat here because I can put the components on the little compartments here, and they won't roll about everywhere. Hopefully that'll fit in there now. Brilliant. So let's see if we can see it on the overhead camera. Hopefully we can, without the camera getting in my way. Yeah, okay. A bit bright, but you know. How's that? Let's come back out. There we are. Pretty much the whole board there in shot, isn't it? Not quite. I'll move it around anyway to suit. Oh, I've disappeared down now. Hey, oh no, I'm in full screen now. Bizarre. Right, let's catch up with the chat then. I could use the Variac Brett, but to be fair, that's got a hell of an output on it. I don't really want to stick it on that because there's no current limit on it. There's no current limit on the Variac Brett. Just run a pair of PP9s in series for testing purposes. Alternatively, I'm sure it will run fine on 12 or even 10 volts. It's got a 15 volt. It's got a 15 volt regulator on it, error 52. So we need to be running at higher than 15 volts for it to regulate down. And I've got the bench power supply there, which will run up to 32 volts. So we can run it on DC, and I don't think it'll hurt on DC. You have got a schematic in the back, actually. That's interesting. It's more like it. 15 volts RMS, AC in, or 20 volts DC. Ah, there you go, look. 20 volts DC, apparently. Let's see if I can get that on the camera. Yeah, sorry, it's sideways, but so down here it says 15 volts RMS, AC in, or 20 volts DC in. So looks like we need to feed it with 20 volts at 500 milliamps, I think, and that should be fine. Still a fair bit, isn't it? Half an amp. So yeah, there's our bridge rectifier. If you can see that, it's a bit dark now, and it's typical. So there. So we've got a couple filters there by the looks of it, and yeah, I thought that was a fuse there. S3, 1000 microhenries. S2, oh, maybe that's switches. double pole switch then maybe. Apologies for it being sideways, but I don't think it'll quite fit in the camera shot. Then it looks like we've got an LED, and there's our 7815 regulator and a 78L05 regulator. So we've got a 15 volt regulator and a 5 volt regulator. Yeah, so we've got a 15 volt supply coming off there, look, and a 5 volt supply coming off of there. Nice. Then we've got analog devices, SSM2166P preamp with variable compression. And more ICs at the top. And this is our dip switches, I take it, here at the top. Interesting. Half an amp at full volume, yeah. 3 volts above 15 should be a minimum DC input. That's right, Harvey. As I say, it's saying 20 volts for DC, so I can certainly wind the power supply up to 20 volts and give it a feed. Right, let's get on and build this thing now. Am I going to be able to turn my light on? Or is that going to blow it right out again? That's not too bad from the side. I need the light on because it's a bit dark. So I think what I'll do is I'll go through this book bit by bit and we'll do it as exactly as it says. Starting with, I believe it's all the resistors. So it's even got, it even lets you know what the resistor colours are. So it's a pretty comprehensive manual, really. Unfortunately, I believe we looked at SSTRANS the other day, didn't we? And they're no longer supplying kits at the moment. They're giving support to people that have bought the kits in the past. So if we get stuck and it's not working, then we can get hold of them. So first thing we've got to do is pop all the resistors in. Temporarily tack solder. Yeah, we shouldn't need to worry too much about solder. And this is all of our resistors. And there is quite a few. So let's crack on and get them done. And there's a lot of different resistors. In fact, they're nearly all different. We've got the resistor package as well. So there is a little clause in there that's saying about if I get the zoom back out a bit, because we are in a bit close at the moment. Yeah, there's a little paragraph here at the bottom, look. This refers to R18. It says, install R18 if you'll be using the supplied wire antenna for in-home broadcasting and you want to use a frequency below 100 kilohertz. What else does it say? If you'll be operating at exclusively above 1000 kilohertz, do not install R18. Also, do not install R18 if you'll be using the external base-loaded vertical antenna. Well, we're not going to do an external antenna. So really, if we look at a frequency below 1000 kilohertz, so that's in the medium wave to long wave range, isn't it? So it looks like we do have to install R18. Okay. So I'm going to go through it as it says in the instructions. Let's line you up vertical, horizontal even to the board, so you can see what we're up to. Rolf, battery buffers. Rolf, I did get your email, mate, but I haven't watched your video yet. Apologies, I just haven't had a chance to watch it yet, Rolf. But I must see that. That's good fun. Cheers for doing that. What else did we have to mention? There was battery buffers and something else, wasn't there? I can't remember what it was now. So if you're wondering what the hell's going on the giveaway video, we talked about battery buffers, which Rolf absolutely loved, and he decided he was going to put that into his latest video. So if you have a look at Rolf's house on YouTube, then you will find his latest video mentioning battery buffers. Excellent. Right, let's pop the soldering iron on. Got my solder already. So we're all ready to go, look. Don't know, but it's probably easier to have the overhead camera view. You can see what I'm doing then, can't you? But so I'm using just my solder reel. Makes it a lot easier to have a reel, so very useful bit of kit. Iron is currently set at 410. I can't remember what I was soldering for that, but we want it back to around about 350, I think. Normal use. I don't know what they tell you about soldering. I mean, really, you should clean the board first, but I'm going to use flux on it anyway, so it should alleviate the need to clean it. But ideally, you just go over it with a Scotch pad or something and just clean it before you start soldering. So basically it says stick all of these in first, flip the board and then solder them up. So I need red, red, black to start with. I'm not colourblind, but the light isn't great here because I can't have it on. So where's red, red, black then? There's a red, red there. I can't even get hold of these things. Not sure if that's black or brown. It's certainly a red, red. I think it's brown. I'll have to get the old goggles on. That's red, red, yellow. Green, red, red. Red, red, black. There he is. I think that's the first one. And that is R8. So let's switch over to the overhead camera. Thomas, how are you, mate? Thomas Kits. You use 567 kilohertz, Les. Are you putting the chips in sockets? I think they've got sockets with them actually, Anthony. So yeah, I think that's definitely in order. Marky, how you doing, Mark? Benji's in. How you doing, Benji? You've been in the workshop. You own a Spitfire. Yeah, I've got a Spitfire as well. I think you can alter the frequency on the Spitfire as well, Mark. Afternoon, Mac Vision. You've got an isolation transformer now. You just need a variac. But Rome wasn't built in a day. Well, you're halfway there, aren't you? Isolation transformer, at least that'll give you a bit of protection, Ralph, won't it? Right, I've got my cup of tea. I'll finish my cup of tea. I'm probably going to want these on to see these colours because these are quarter-watt resistors. That is definitely red, red, black. So that is 22 ohms and it's going in position R8. So let's get you in a bit closer. So it looks like we're starting over this side. Darken that down a touch. So R8 is here. I haven't got one of those fancy lead bending things, so I'm just going to have to go old school. Pop it in. Just grab the legs from underneath and just straighten it out. So that's the first one in, R8. Now R3, 100 ohms. Brown, black, brown. brown, black, brown. There we go. And that is R3, which is in there. There's a toss-up between doing this or looking at some more radios today, because I've got some more radios from Dougie. I've got another 3 to look at, but I wanted to get this built because this will help us when we start using the other radios. So R25 then, red, red, brown. That's one of these. It's brown, isn't it? Not purple. Yeah. R25, 220 ohms, red, red, brown. R25, come in R25, where are you? Oh, right away over here, that's useful, isn't it? You can't see, that's probably just out of shot there. Bam. 25, then we got another 220, red, red, brown, so that's that one, I think. Brown looks very much like purple though, doesn't it? So another 220 in R28 position. Where's R28? It's not very neat. 26. Oh, okay, yeah, there's a bank of resistors down here, so it's in one of those. So we'll try and put them all facing the same way. I don't know why they're going to random numbers as you put them in the board, but we'll go with what they say. They know better than us. And another one in R29, another 220, red, red, brown. R29 is the one just above it. Battery buffers. Right, now we're jumping over to R7, which is green, brown, brown. Green, brown, brown. R7, that's going to be back over this side. Yep, that's back over here. R7. Better to have it like a kit and like this than having to well, it's nicer to build something and actually get it working, isn't it? Oh, I haven't done with that. It's done a runner. Okay, so R18 then, this is the one, this is the question mark one. Well, we are going to install this because we'll set it up under 1K. Grey, red, brown. It's grey, red, brown, there we are. And that is R18. R16, R17, R19. Where's R18 then? Anybody see R18? Come on, there he is, right over that side. That's bizarre. It's over that side. Next one, R12, 1K, brown, black, red. Brown, black, red. Bread. 1K, R12. Sounds like bingo, doesn't it? 1K, R12. in the middle. Another 1K R21, which is brown, black, red. There we are. Brown, black, red. R21. R23, R21's over here. There we go. And R31 is also 1K. So we should have another one here somewhere. There we are, brown, black, red. R31 over here. Right, 1.5K now, R17, brown, green, red. Is it going to be anywhere near R18? No, it's not. R17's over here. It's certainly blowing a bit of a gale out there today, I can hear it. R27 then, 1.8, brown, grey, red. R27, that's got to be over here. I don't have to use the magnifiers, but it does make it a lot easier. I don't know if anybody else does kits for these. Let's have a look then. Generation, how you doing, mate? We've got a few more joined us. Hang on a sec. Let's have a look. We've got Keith. Afternoon, Keith. Happy birthday for yesterday. It has dip switches. It came tuned to 1440. You retuned it to 1566. Yeah, I did do mine, Mark, but I can't remember what I set it on now. Afternoon, Jess, how are you? Soon there will be a new pirate station in Devon. I don't know what the output of this is actually. I don't know if it says in the spec in the back. I think I'm okay to use it because I've got a full amateur radio license. Let's have a look, see what it says. Power consumption. Power input to final RF stage, 100 milliwatt. Doesn't tell you. I don't think it tells you. I don't think it tells you unless anybody can see it there on the spec, but it's got frequency coverage. Maximum modulation level, power input to final RF stage. So it's 100 milliwatts power input to final RF stage. Doesn't tell you the RF output though, does it? RF output metering, RF grounding options. RF grounding is pretty essential on these things. So yeah, it doesn't really tell you there what the actual RF output is on it. RF output tuning range. So it's got quite a frequency range. You can tune it from 479 kilohertz up to 2523. So 479 kilohertz up to 2.5 megahertz. It's got quite a range. It doesn't tell you what the output is. Les may well know. She came in from the garden, Jess, doing some work outside. It was not too bad today, is it? Afternoon, Derek, how are you? You've got FM Pirate Station here in Cornwall on FM local only. There is Pirate FM in Cornwall though, isn't there, Jess, as well? Yeah, back's a lot better, Derek, thank you very much. You've got a 25 watt FM broadcast unit, have you? Oh, you don't want to be you don't want to be advertising that, Jess. Shh, keep it quiet. Generation, how are you, mate? Do you happen to know what they use to transmit RF from DC 0.01 Hertz and above? Does that connect to coil winding or something differently else? Do you happen to know what they use to transmit RF from DC 0.01 Hertz? I really don't know, Generation. It is fun to build kits, Generation. Mike Atlantis, how you doing, mate? I'm just catching up with the chat here. So yours is 25 watts on FM, but you only use 0.5 watts on your broadcast unit. That's fine. Doug, how you doing, mate? 3 watts is a lot for a transmitter. It is if you're just transmitting in-house Generation. If you stick 3 watts on something like this, you'll transmit throughout the town. It's got a great OptiMod limiter. I'll take your word on that, Les. 3 watts is half a mile. You can get a long way on 3 watts. Graham, I didn't say how far it would go. To the end of the road. Yes, it would. 100 milliwatts, you think, Les? It's 100 milliwatts to the final stage. I don't know whether the final stage amplifies that any further. So you want to build a random RF noise generator. You're trying to block someone out, Generation. You're my bad back, Mike. Oh, sorry to hear that, mate. You can hardly walk. I know that feeling. I've recently started going back out walking with the dogs, so I am sort of back in action now, so to speak. Anyway, let's crack on. Let's crack on and get this thing built. Let's get this thing built. I need to get my cup of tea down because I'm feeling. Oh, hang on, what's going on here? Wrong button. I'm feeling the need for a beer. Right, now this is the problem now. I forgot where I was last. So R4, I think, is next. Red, violet, red. Red, violet, red. There we are. Violet is the colour that I always get confused with. And that is in R4 position. R4. There he is. R4. And then R30 is yellow, violet, red. Tell you what, these goggles make a big difference. Yellow, violet, red. There he is. R30. It's got to be over here somewhere. There he is. Up with my little bank of 5 now. Try and get them all level, make them look nice and pretty. R10, blue, grey, red. R10. R9, R10, there we are. We're nearly halfway on the resistors. 8.2 ohms, grey, red, red. Grey, red, red. R6. Crack on, let's get these put in. It seems that this is what there is the most of. R6, where are you? R6, come in. R6, R1, R2. R9, 10, where's number 6? There's no real organisation as such to the screen printer. There's R5. So you think R6 would be next, wouldn't you? But it doesn't appear to be. S6, R19. Where is it? R23, R11, R6, there he is. Bizarre, nowhere near the R5. R6, R19, brown, black, orange. And we've got 3 of these, so that's R19 first then. Let's say a lot of these modern kits now are coming with surface mount components, which I quite like personally, but it's not to everybody's taste. Some people do not like those. Another brown, black, orange. R22. 22, okay. And there should be one more, brown, black, orange. That one's going in R32. Where's R32? Who knows? I think they do this to slow you down, you know. 15, R14. It's going to be right over the start here somewhere, isn't it? Oh yeah, it is as well, look. Right over here. So that was R32, now we're going to R16, brown, green, orange. Power output would depend on the efficiency of the output stage. With 100 milliwatts input, you could expect 60 to 80 milliwatts output with an efficiency of 60 to 80%. Cheers for that, Doug. Let's see what it says. It did say what its efficiency was here, so let's have a look. Oh no. No, that's RF modulation level was 100%. I know I did some work years ago where we worked out the efficiency of stuff like this, and I can't remember how I did it now, but I know it was maths was involved. Right, what is this one then? Brown, green, orange. R16. R14, R15 is over here. So R16 is probably over here somewhere. That's over here, yeah. That's crazy, isn't it? But I'm sure there's this method and how they've laid it out. I suppose the software they've used determines where the parts go. Right. Red, yellow, orange next. Red, yellow, orange, and that is R23. So we're running out of places to fit some parts now, so we should start getting easier to find them. He says R23, where are you? There it is. My soldering iron will turn itself off in a minute the way we're going. R23. Then R1, red, violet, orange. R1. Another red, violet, orange, R2. And another one, red, violet, orange. We're nearly there, not many to go now. R5. Orange, black, orange. R33. Yellow, violet, orange, which is in R9. Yellow, black, brown, black, yellow. R26. Hopefully we won't have any missing or any left over. R26. Shouldn't have said that really, should I? You bet your life that'll happen now. R26, red, red, yellow. You do tend to find the Chinese kits are either too much or too little, one or the other. R14. Brown, black, green, nearly there. 1 mega ohm. In fact, all of these are 1 mega ohm now, so I don't need to worry about them. R11. Come in R11, where are you? There's not that many left now. R11 down there. It's gone over a bit far, come out. R15. Still can't find the blimmin' things. R15's got to be over here. There he is. Oh, come back. The last one, R20. So hopefully we can start soldering. Whew. Right. Cheers, everybody. Let's get some beer underway. Yeah. So that's the story so far. And today, for your drinking pleasure, I've only gone and got the finger. So we've got the finger back in the house, look. Can't beat a good bit of fingering on a Sunday. Let's see if I can find the opener. Let's get the bishop's finger inside me. Let's catch up with the chat then in a second once I get this poured. It's a bit feisty today. It's going to take a couple pours, that. A bit feisty. Let's catch up then with the chat. Puts a good signal around the house, doesn't it? You wish you had a signal generator. I'd like to have one for radio alignment, but heck, they're expensive. Yeah, they can be, Ralph. You can pick up a cheaper one. I mean, the best place is to look, if you've got an amateur radio rally coming up, mate, that's the place you want to go for a signal generator. I've got a couple from there before. SMD, some of them must to have a stencil maybe and a good tweezers. Yeah, you don't really need a stencil unless you're using hot air, really. Les can't see SMD. And what's Mike saying? Does anybody know if the speaker output on a Hacker Hunter amp board, if the speaker output on a Hacker Hunter amp board are easily fixed, as the black one on mine is loose and had to use a blue tack to get connection? Do you mean like the little tiny coloured things that go on them, Mike? Have I got one here? Do you mean these things? If I can get it to focus. Come on, camera, focus. Focus, there we go. Do you mean these little things here, Mike? Is that what you mean? No, it's trying to focus on the board. Get off. SMD is good for Rolf's house. DIY get cheaper. Think of that. Needs display though. Benji, have you missed anything? I don't think so. Rob, how you doing, mate? Rob Cross. 100 milliwatt to the final stage is the maximum allowed by FCC for Part 15 unlicensed transmitters in the US. All right, okay, Doug. Benji's been in the kitchen. What are you cooking for us today, Benji? Spanky, How you doing, mate? Kit's never been apart. You only had a peek inside. Looks like a fine beer. Fine bear. The bishop's finger's back. I've got the finger going in me today. Thank you, Rob. We're building an AM transmitter today, mate, so as you can transmit a signal around the house to pick up on your old AM radios. A vector signal generator is much more expensive. Thanks for this super chat, Rob. Great stuff, mate. Thank you very much. Yeah, that's them, but not the plug, the thing the plug goes into. Oh, you mean the connector, the 2-pin connector? You got that? You've lost that, Mike, have you? Sorry, not the 2-pin, the plug connector. Let me just see what you're putting. I don't even know if the speaker output. Easily fits. There's a black one on mine. It's loose. They're only soldered on, as far as I'm aware, Mike. They're only soldered on, mate. So it's literally you've got to bear the wire back, poke it down the hole of the connector, and then just solder it, as far as I'm aware. I'm not 100% sure on that, Mike. I'll have to get one out later. Remind me later, Mike, and I'll pull one out and then we'll have a look. I think you mean the actual pin that goes into the sockets there. So you're on about the pins from the speaker that go into that. I'm pretty sure they're just soldered on. You can pick up signal generators quite cheap if you search around, Rolf. I think my little wobulator there cost me about 50, 60 quid, I think, so they're not mega money. Obviously something like the Stabalot behind me is 1,000 quid, but you can pick up sort of an older style one cheaper, but they tend to not be quite as accurate. But it depends what you're using it for, really. If it's just for a rough and ready alignment, they're ideal. I've nearly got all of the finger in the glass. The finger's nearly in. You can't beat the bishop's finger on a Sunday, can you? I've missed the finger. And for those that are wondering what the hell's going on, I mean, the bishop's finger is these old signposts. You see that with the looks like a pointing finger, doesn't it? That is what they call a bishop's finger. Not actually the finger of the bishop, but you know, you can interpret it however you want, really. Not the pin, the part on the board that the pin goes into. The black one is, oh, I see what you're saying. So you mean the underside of the board here, Mike? Is that what you mean? No, you've lost me a little bit. You mean this bit that I've just uncovered? If it'll focus. Come on, focus. Yeah, okay. You mean this bit, Mike? The little stub that is soldered to the back, if that's what you mean. If not, then you've lost me. Okay, so that's all of the components in there. You certainly don't want to be attaching those with blue tack either, Mike, because if they don't make connection, you could take your output transistors out. So well worth making sure they fit properly. This camera's a bit doing some weird stuff today. Where are we? There we are. Okay, I think you can see where we are. So I'm going to flip it now. And we're going to solder it up. Got it at a bit of an angle so I can see it better. Let's get my beer out of the way because we don't knock that over. I've had the finger for a long time. Right, where's my flux then? Come on. Who's at the flux? Give flux. Fluxy, fluxy. What have I done with the flux? This normally rests there. Have I knocked it off anywhere? Excuse me a minute. What's the best range for a signal generator? There it is. Best range, it depends really what you're looking to tune up, doesn't it, Ralph? If you're looking to do FM, then really you need it to cover the FM band range, which is up to 108 megs. And the other thing, you need to make sure it covers the long wave as well. So really you need something from like 100 kilohertz to 110 megs, really is ideal. That's got FM as well as AM modulation on it. So I've gone and emptied my flux out, so I need to find my flux and top it back up now. What the hell have I done with that? I might have enough actually in here. I've got very little flux left, so a little tiny dribble in the bottom because it's fallen down behind. Anyway, let's get these soldered up now. Ideally, I ought to get the fume extractor in. Everything's a little bit packed out here at the moment. I don't know why. I've got too many things on the go again, as usual. Got a bit of a dispute with a Chinese company at the moment that's sent me some damaged speakers, and they don't seem to want to replace them until I remove the dispute. Well, I'm not going to remove the dispute until they've settled the dispute by replacing them or refunding the money. So I'm really not sure on that. They say they can't replace them or refund until I remove the dispute, apparently, which I think is a load of rubbish. So right, I've got the extractor in now. So we're going to have a bit of noise, but it's better than me breathing in a load of soda fumes and flux mainly. Flux is the bad stuff. Yeah, if the pin is loose on the board itself, then it needs soldering back on, Mike. So I'm just going to go and touch these up with a little bit of flux, all of these, because I say I haven't cleaned the board. Ideally, you want to clean the board before you solder these with a Scotch pad or something like that. But flux will stop it oxidizing. It will remove some of the oxidization on there. That's the object of flux, is to stop oxidization. So just going over and fluxing all of these. We've got enough flux left to do it. There we go. Right. So I'm going to put the fume extractor on. Apologies for the noise in advance, but it's better than me breathing it all in. So here we go then. You need to be fairly aggressive with the heat on it, just to make sure it goes right the way through the board to the other side. Can you see what I'm up to? See the light shining all over it. I think you can see roughly where I am. Yeah, okay, I'll go this way a bit. Yeah, these modern boards are a lot more robust than the old boards we used to working on with radios, so you can be a bit more aggressive with the heat on these. It's through-hole components, so you want to make sure that you've got a good connection, and ideally the solder wants to travel through to the other side. Again, you don't want to put too much solder on like I have done on that one, and make it look a horrible joint. Extractor doesn't seem to be extracting a lot, does it? Because my hand's in the way. I always recommend that you start with the smallest components first on a board build like this. This is the fun bit, isn't it? Soldering it all in and cutting the wires off. Make sure you've got them all. Right, I think that's it. Let's just catch up with a chat a minute while I've been doing that. Back on the ale. Just the odd one. Just the odd ones, Mr. Spanky. Just the odd occasional one, mate. So, cheers. Certainly is, Les. Yeah, so I mean, if you look at mine up there, that's a Philips HF generator, 100 kilohertz to 110 megahertz. And you want something with a fairly decent output as well, Rolf. Avoid a frequency. What's the word? I think they call them frequency. I can't remember now, but there's just get an RF signal generator, not just a. What's the word I'm looking for? Right, let's do this snippy and get these legs off. Let's snippy these legs off. Hopefully I've got them all soldered. This is where we find out that I've missed some. I'll cut them off pretty flush because I'm going to just go back over the board with the soldering iron and just touch up after I've cut them off. Just in case we've got some got one that's not quite gone properly. Oh, hopefully that hasn't gone in my beer. Yeah, so I'm not really back on the beer spanking. I have an occasional one, don't I? I usually have a Guinness, but I'm prepping myself for Christmas because I've got 24 beers are going to be going my way on at Christmas. And it's not that far away now, people, is it? I hate to mention the C word again, but, you know, it's always fun for us because you get a live stream a day then, don't you? Potentially. I haven't decided exactly what's going to happen yet, but I think that seems to be the norm and everybody misses it once I stop. I'm going to have to get some more cutters. I think these are starting to get a little bit worn now. It's a satisfying bit, isn't it? Cutting all the wires off to reveal your handiwork. Apologies to my Patreons as well, because I've not really done anything on Patreon since I've done my backing, because I haven't had a lot to show you. Doesn't look like I've missed any joints, which is good news. I haven't really had anything to show you because I haven't done anything. So they all look nice and flush. That one's a little bit proud of the board there, so I might just heat that one up and pop it down. All the rest are nice and flush, apart from that one. What's gone on with that one? Bizarre. Okay, so I'm just going to quickly go back over these. Just makes a nicer joint underneath once you've cut the things off. Makes a much neater joint because when you cut the legs off, you cut into the solder a little bit. You leave a shiny end on it, so there we are, all nice and neat. Right, let's get rid of all these legs. Well, actually, no, I don't need to worry about them for a minute. You've got a brake job, Keith, have you? Got to go early today. Okay, mate, no worries. Christmas Eve live stream is always best with Hunter versus 707 Shootout and then Zorba on the record player. Yeah, we usually get in trouble on Christmas Eve, don't we? But yeah, I'm sure we'll have lots of giveaways again this year. I'm hoping that I might get another Wera advent calendar, so if anyone from Toolstation or Wera is watching, you know, if they want to sponsor the Christmas episodes with a nice donation of a Wera advent calendar, that would be very nice. Usually Mrs. Cruncher gets me one of those for my birthday on the 5th of November. Right, so that's the resistors in. What's next then? What have they got in store for us next after the resistors? Probably diodes, is it? No, it's chokes. Chokes next. So they say that the IC's already soldered onto the circuit board. You should look at it to verify it's present and familiarize yourself with its appearance and location. It's marked SSM3166A. Well, that's the little beauty there. So our little SMD package, which is upside down, but if I flip it, will that put it the right way up? Yeah. So it is indeed an SSM3166A, which it is. Ideal. So it's already soldered. As I say, it would have been fun soldering that on there, but they've spoilt my fun now. But there you are, it's on. And you can see the rest of my components all soldered on. See the solders come right the way through to this side as well, so that means they're all good joints. In fact, it has all flowed through pretty well, apart from that one there. I don't know whether that one's on a big ground plane or not, but yeah, that one that I said's proud from the board is the only one that hasn't really soldered that great on this side of the board. All the rest have come through very nice. It has soldered because I can see the solder there actually, so I'm not going to worry about it, but yeah, ideal. So let's zoom back out again. Oh, steady. Apologies. Doing your heads in now. Right. So it looks like the inductors are next. L4 to L8. Now we should have a little pack with the inductors in it here, which we have. This one, coils and inductors. So it looks like we're looking at the normal ones. These look like resistors, so don't get some inductors and resistors mixed up. So it's just as well they put them in separate back, because they do look exactly like resistors, don't they? But they are inductors. We've got some wire wound inductors in there as well for in a minute, but we're not looking at those yet. So L4 is green, blue, black, gold, 56 microhenries. Green, blue, black. We've got green, blue, black, silver. So I think silver and gold are just different tolerances. Let's make sure I haven't got another one. Green, blue. No, so it is, they've got that one wrong then. That's actually silver. I'm not sure if silver's a higher tolerance than that. I'm not sure. That's an Optimod chip, is it? Okay. It looks like analog devices, doesn't it? That's the little symbol for analog devices there. Okay, so that's the first one. Let's get these out of the way before I get confused about which is which. So this is in L4. So it looks like they're all over here by the looks of it. L4. So it's good. So anybody know what silver and gold tolerance is? One is 5% and one's 10, I think, but I don't know which way around it is. L5 is grey, red, black and gold. Grey, red, black and silver. That's L5. No, that might be gold actually. That might be gold, that one. Then 180 microhenries is brown, grey, brown. Brown, grey, brown, gold. There we are. L6. I say they do look exactly like resistors, but they're sort of a little bit stubbier and they've got a slightly different shape than a resistor. L7, yellow, violet, brown and silver. Yellow, violet, brown, there we are. L7. So this is probably in the frequency generation part of the board, I would think. This one looks like a bit lumpier, so it's higher wattage part. Be in the transmitter stage actually. And the last one, L8, 1000 microhenries. So we're going to get one left. It should be brown, black, red, and silver was brown, black, red, and gold. Oh well. Let's say the last figure is just the tolerance on it. That's in L8, which is in there. So let's get them burnt in. Best to put those on the LCR meter to be sure. I'm too late now, I've put them in. Silver's 10%, gold is 5%. So you think they'd all be gold really, wouldn't you? But I mean, we can put them on the LCR meter actually. We've got time. Let's get me little probies. We'll stick them on the LCR meter, just see what they measure. It's just whether they're in series with anything or in parallel with something else. They might not measure right. Get the little stand. He says as he chucks it on the floor. So it would be interesting to measure them. Hopefully you'll be able to see that. So let me have a look which way round it is. So L4, 5, 6, 7 and 8. Okay then, L4 first. See if I can measure that before we solder it in. Now it's in capacitor. So it's reading 55.6 microhenries, and it should be 56. So it's not far off. It's within the tolerance. It's got a silver band, that one, not a gold one. If it was gold, it would be closer, I expect. So next one's L5. And that should be 82 microhenries. It's reading 78. So a little bit low, but not far out. So it could be that it's in parallel with something else. Next one then. This should be 180 microhenries, and that was absolutely bang on 180 there. Bang on 180 microhenries. L7. Should be 470. That one's low. But I think that's across that resistor. It's 435 that one's reading. It's supposed to be 470. So we might take that one out for a look in a second then. LA, I mean, it's not going to hurt, to be fair, because we've got adjustment on it. And the last one should be 1000 microhenries. It's 974. So again, it's not great, but so if I disconnect that one and just pop that one out a minute. Last one. See what it reads out of circuit. So it's supposed to be 1000. Yeah, so it's fine. Out of circuit is fine. It's just because it's across a resistor, I think. It's changed the value of it. So let's pop that back in. Where are we? Around that way. Let's burn it on. Let's solder it up. Yeah, they are a bit difficult, Doug. Right. Let's get some flux on them again. Extractors on. Going in. Got some more computer stuff coming up at some stage. I might save that to Christmas. I've got some Commodore 64s, and also I've got an Amiga to build. If you remember, I bought a brand new board last Christmas for an Amiga because I didn't think I would be able to get mine working, and I amazed myself and got mine working. But I was quite looking forward to building a brand new Amiga, so that will happen. I'm not sure if we'll do that over Christmas because it'll probably take up about most of Christmas because there's a lot of components to solder on. It says that Mrs. Cruncher's going out with the doggies, is she? Just have a look. Yeah, looks like she's taking the dogs out to the woods. They'll like that. Or out to the Tarka Trail, one or the other. Right, so I'm just going to go over those again and just touch up the pads just to make sure. There we go. So now we have our inductors and our resistors on the board. It's looking busy. How are you all doing, people? Anyway, you're not all too bored, are you? You're not falling asleep, are you? Unlike me. Right, let's have a look. What's on next then? Rectifiers and diodes now. So rectifiers. Where's our rectifiers and diodes packet gone? Inductors, fixed capacitors, miscellaneous, integrated circuits, sockets. It says here, observe precautions for handling electrostatic sensitive devices. Great. So let's just pop my wristband on, just in case. I'm not expecting to zap anything, to be fair, but better safe than sorry, isn't it? It's suspended on plastic things, so I don't think we're going to have any issues there, but I will put my wristband on if I can dig it out from underneath all this cabling. I've really got to get my act together next week and crack on. I've got some repairs we've still got to do. I've got an R707, I've got an airband radio, I've got to do an LED modification on one. So putting the old wristy band on, just in case there's anything static sensitive in there. I could just discharge myself onto the filing cabinet. That doesn't sound good, does it? I could just touch the filing cabinet to get rid of any static, really. I've got a big metal filing cabinet beside me. I'll do that anyway. So, fully static sensitive sorted out now. Let's have a look at the diodes then. They've got to be these here. So that's diodes, we've got transistors there, ICs, quartz crystal, voltage regulators, etc, etc. Right, okay, but it's only the diodes that we're looking at the moment. So we've got 4 1N4002s and 2 4148s. Standard, all very standard diodes. Nothing rocket science there. Let's go to the overhead camera. So yeah, that's the rectifier diodes. Those are there, and that's the 1N4148s. And they are marked, but they are very hard to see. These are, what are these? These are 1N4002s. Okay, so this D1 to D4 is the 4002s. I did spot them just now. That's in the center here. D1 to D4. We're all gone quiet. Are you nipped out for a coffee, or you've fallen asleep? You're bored senseless? So we've got a little marker on the board to show which way round they go, which is very helpful, because I always get confused with bridge rectifiers, which way round they go. So again, probably worth just spacing them off the board a fraction, because these can get warm. Don't really want to put them down dead flush on the board. There we go. Oh, one. Okay, and the other two, D5 and D6, are the 1N4 and 48s. So where are they two? Over here. Again, the little stripe is marked on the board. D5. D6. I'm sure you can see that this this little jig, this little PCB holder does make life a lot easier. So well worth getting if you're doing a kit like this, or any kit really. Which reminds me, I must get that probe built for the Velleman kit, signal tracer and injector that I did. I still haven't done that, have I? Right, let's get this burnt up then. On with the fan, in with some flux. We're motoring through it now. Floppy's still watching, are you? Well done, Floppy. How you doing, mate, anyway? The legs on these rectifier diodes are a lot thicker, so they need a little bit more heat. There we go. Where's my clippers? Where's my snippy snippers? Okay, just go over those again with the soldering iron. See the two gone in there. There we go. Look at that. We really are smoking through it now. You're still here. You have a kit radio to build as well. Oh, good stuff, Derek. I've still got one of your radios here to build, mate. You're still putting your Tesco delivery away, Marky, are you? Floppy's recovering from a hangover. Good one. Let's have a look. Ralph is sorting components and tidying up while you listen. Anthony's got two of those Duratool, but one I've made the bottom bar a bit longer on one of them. Yeah, I suppose you could run out of space if you've got quite a big board to build. Okay, what's next then? What do they want next? Resistor network now. So this is saying important, orient the resistor network SIP package so the dot marking pin 1 is aligned with the dot on the board outline. So the thing they're referring to is this thing here. So let's zoom in on that so you can see what So this is a resistor network, so there's lots of resistors in one package all tight together here. And you can see there's a dot on this end. So you need to get it the right way round. So it's in R13 and you need to put the package so the dot marking pin 1 on the package is aligned with the dot on the board outline. Well, luck has it we're right by the resistor thingy there, look. And you can just about see if I can work out which way I'm going with it. There we are. So it's R13 and you can see that there's a mark. It's not a very good mark actually, just here on this, just on this edge. So that's got to line up with that pin number 1. So it's got to go in the board like that. So I think with this one what I'll do is I'll just bend 2 of the legs, one way and one the other. And that should hold it, if I can bend it, in the board to enable me to solder the rest of them up. There we are. So I just bent 2 of those legs up. Just held it in place now. Make sure we're straight. Not that it matters to be fair, because these do bend quite easily, but as you know, I'm a fuss ass, so I will bend it. So let's just solder that in. Bit more flux. It's easy. It makes a nicer joint if you don't bend the legs at all, really. But you'd be there forever trying to tack one and then do the rest, wouldn't you? Let's just have a look. That's nice and straight. Yeah. Let's do the rest. You don't need to cut that off either. Nice. The only thing I can see is some of the solder's flowed through to the holes of S4. So I'm going to have to wick that off, otherwise we're not going to be able to solder S4 in. So let's just wick that off a minute. You can see where it's filled up those holes. Let's just put a little bit of flux on there. So I think we've got to put a socket in there or something, possibly. So let's just wick that out. There we are. Just cleared those holes out. I think we've got to put a socket in there. I'm not sure. Oh, that's a switch bank, isn't it? Yeah, of course, that's the switch bank. So there, I've just cleared those out. Did not off earlier. Too much beer yesterday. You can't knock a bit too much beer. I've just had the finger, so I'm sorted. Okay, what next then? IC sockets next then. So, again, we've got to orient. This is our IC, integrated circuits, dip switches, and 16-pin IC sockets. It's good they give you sockets as well, isn't it? I mean, that's pretty good. So here's our sockets. We've got 4 sockets by the looks of it. And we've got dip switches, but we're doing the IC sockets first, and they're all 16-pin. So U2, 3, 5, and 7. So let's get those out. They're just, well, they're double wipe sockets. They're not too bad. So basically, what they're saying is you need to make sure that there's like a little U in the end of each. If I can get it underneath the camera, there's a little U on the end of each socket. Look, can you see that? It's a little U cut out on one end. And when you look at the sockets, you see there's like a little U on the screen print as well. So what's this? U2, 3, 5 and 7. So yeah, you can just about see that there's a little mark on the board just here. You can't quite see that one, it's just off the camera, but so we need to make sure that the sockets are lined up with those. So I think with these we're going to need to tack these. So what I'm going to do, I'm just going to put a little bit of flux on 2 corners. You've got to be careful where you're holding this as well, so I'm going to hold it in the middle so I don't burn my fingers through the other side. So I've fluxed it already. I'm just going to put a little bit of solder on the end of my iron. I'm just going to... Did I flux that one? And that one. There, that one's held in now. And the next one, U3. Let's do the same. Just gonna flux 2 opposite corners. Bit of solder. That one's in, tacked, tacky tack tack, U5, they're tight together, aren't they? Oh, hang on, we've got another blocked hole down here. So let's, where is that one? Okay, so a bit of solder's flown across from that resistor, so let's get rid of that as well. Hopefully, where is it there? Try again. It's better. Tight together they are. Tack that in as well. And the last one, U7, making sure we're the right way around. The fact and we've got another blocked hole down here. That one there's blocked as well. Let's just get that cleared. So again, we'll just tack opposite corners. There we are. So they're all tacked on now. So just a case of soldering them on. So let's just get that sorted. So I'm going to flux them all up again. I will resolder the ones I've tacked as well because they are only tacked. Extractor on. Let's go to the overhead camera. Let's get these soldered in now then. So I've gone over the ones that I've tapped as well. There's a lot of grounds there by the looks of it. A lot of soldering, but very therapeutic, I think. Doing kits is great fun. And usually you do get pretty good support from the manufacturers as well, so if you're a bit worried about doing kits, don't be, because it gives you a lot of pleasure, really. Got to thank Les again for donating this kit for us to do and have a play with today. I think that's all of them done. Looks like it. Make sure we've got no bridges. Doesn't look like we've got any bridges, which is all good. I'll give the board a clean off after it's finished, but there we go. You've had a nap. Really pleased you just found some forceps in your late father's cupboard. Blooming handy for removing old caps in valve sets. Definitely. Yeah, you're very keen at doing kits, Derek, aren't you? I think it's much better than buying one built up, I suppose. I mean, you've got to watch what you buy, because sometimes they can be really complex and you need a load of test kit to actually put them together. Well, not to put them together, but to trim them afterwards. Right, let's get another beer underway a minute. I'm going to go with Old Speckled Hen, low alcohol. Not a bad beer, this one. It says low alcohol because it's 0.5% let. 0.5%. And I've been advised by Mrs. Cruncher that there's absolutely no low or no alcohol beers in the Christmas lot. So we're going to be trying out some very different beers this year, because it's not, although we've used the same advent calendar, there's a selection of beers that Mrs. Cruncher's put in there, and I don't know what she's put in there, so it could be anything. She might put me in a bottle of whiskey in door number 24. What do you reckon? That could be a messy live stream, that could, if she's put me a bottle of whiskey in there. I think the worst time was when I was on the run, wasn't it? So I have got a record player coming up to do. I've got a Dynatron Music Centre to repair and fix up. which was going to be mine, but I think I'm going to end up selling that on because I've accumulated quite a lot of record players over the last few years. I don't know that I need any more, but you never know. Let's get rid of some of these legs in my little spare leg pot. It's not bad stuff, that, but you certainly can tell after having... I should have had this first, really, rather than having the proper one first. I should have had this first, and then I could have said, oh, this is actually not bad. But now, compared to the finger, it's not as good as having the finger, put it that way. So cheers, everybody. Nearly alcohol free. Might all be pop. It could be. It could be nothing. Whiskey's why you had a hangover, Fred, is it? I'm a lover of whiskey, to be fair. I've got very little whiskey left now. Mrs. Cruncher found me an absolutely brilliant bottle of whiskey the other week in a sale. Well, it wasn't in a sale. It was reduced. And it's Lafrague, 10-year-old Lafrague malt whiskey. Absolutely lovely stuff. It's normally about 45 quid a bottle, something like that, but it's down to 20 something quid, which was a bargain. So she bought it for me as a present. That's very nice of her, wasn't it? Right, so that's our IC sockets all inlet, all done. What's next? What is next on our list here? Dip switches next. We've got an 8-position dip switch and a 4-position dip switch. So it's, again, this is got to be orientated correctly. Pardon me. So, dippy switches. That's those. So say we've got an 8-way and a 4-way. So they're marked, apparently, allegedly. I think this camera's about the best, isn't it, for this? I'll swap to the other camera from time to time, but... So yeah, it's got a black mark in the corner, look, so... This is the 8-position one, and switch 1 has got to coincide with that, so that's going to be in there. And this one has got to be over here, and that's that way round. Interesting. There they are. Right, so we'll do the same again. I'll tack them and then go and do all the others when we're in there. So where is it? Here we are. So let's tack. I need to get some more flux in a minute. Let's tack this one in first. See a blobby joint there? Is that one? Let's just tack that. And this one, make sure it's the right way around. You can see this this little board holder is absolutely coming into its own now. I'll go that one and that one. It's quite close to the... Go on, tack, you monster. Thank you. Didn't want to tack that one. Right, let's get them in. Let's get them soldered up. extraction on. Oh, actually, no, a bit of flux. Don't want too much heat on these because it is plastic body, so I'm sort of in and out of these pretty quick. My soldering iron's set at 150. So they're all ground, so they're switching it to ground by the looks of it. So this side is all connected to the same strip. If I don't melt my PCB holder here. There we are. All done. Looking good, no bridges. And there's our dip switches in. Nice. Next, jumper headers. Okay, jumper headers supplies one strip containing 6 jumper header pairs. 5 will be used, 1 spare is included in case you damage or lose one. So we've got jumper headers here somewhere. Where are they to then? I've got them in the miscellaneous pack. Jumper headers. It's got to be those. There's a little jumper to go on top of them there, so ideal. We've got some little rubber feet. So let's have a look at this then. Let's just get my head around this a second. So the jumper headers are supplied as one strip containing 6 jumper header pairs. 5 will be used, 1 spare is included in case you damage or lose one or separate. You'll need to cut this strip into individual single pair pieces. Lay a strip on its side on a flat surface. Place a blade of a sharp knife in the first groove. Hold the knife so the blade will cut through the blade. Single pair. So I've got 1, 2, 3, 4, 5 single pair jumpers. S1 to 7. Where the hell are they? Okay, 1, 2, 3. Okay, they're all individual. So basically, I've got to cut all of these into individual pairs. So let's get that done a minute. Let's move that back off of the bench. So I need to get down there. It says I need to cut down with a utility knife. So I'm going to use a scalpel because that's what I got to hand. I'm going to cut down. Cool. Yeah, that ain't easy, is it? Oh my god. Oh, I found it. That was lucky. Okay. So I need to be careful. I need to cut these a bit more carefully than that, don't I? Actually, you can see better on the overhead camera. There we go. So you better tell me where it pings off to now. 2. Probably the wrong tool for the job, really. I want a bit of a stronger bladed knife for this. Cool, flip it heck. Scalpel's not really the right tool. Where's my utility knife? I've got a utility knife. So where is my normal craft knife, I wonder? Definitely need a Stanley knife for this job. I have got better bit of a stronger craft knife, but as per usual that's disappeared off the face of the planet. Was that it in behind there? Is that it in behind there? No, that's the power lead. Oh, I see it. It's down there. I don't think that's going to be a lot better, mind you. It's slightly better than the scalpel, maybe. Better put these goggles on just in case it flies up and gets me in the eye. Cool, flipping heck. These ain't easy to cut, are they? They're having a laugh. Cool, flipping heck. Yeah, whoever said these were easy to cut was fibbing. Don't worry, my fingers are nowhere near the blade, so they're either side of it, not underneath it, because they'll stop it flying away. God, flipping it. Typical, the last one does not want to go. There we go. Got him. Wow. That's not great, was it? So that one's a little bit bent, so we'll leave that as our reserve one. The rest all look fine. Let's get back to it then. You notice you solder those resistors from above? You don't solder these from above, you solder it from below according to the manual. But it comes through anyway. It comes through the whole generation. They're going to be legless. I used to live with a woman who drank more than I was comfortable with, and I've not touched a drop since. That was 20 years ago. Just drink tea now. Oh, good for you, Ralph. Mrs. Cruncher likes a drink. Only tea for Benji. Tea and banana bread, Benji, isn't it? Ralph goes to Upton Blues Festival with a big flask full of tea. Doug's saying cutting the headers is a pain. It certainly is, Doug. Just checking the chat a minute. I wonder what those dip switches are used for. To set the frequency. Yes, they are, yeah. Chainsaw, definitely. Yeah, they're through-hole parts generations. So if I zoom you in on the board, you can see that the solder's come through the other side. I get you sort of at those in the middle of the shot there. You can see there's a nice solder blob either side of them. If I flip it over, they're soldered on the bottom side as well. So it's through-hole components, so it solders right the way through. You with it now, generation, excellent. Okay, so where have these got to go? These have got to go in the S positions, haven't they? So you just short these, basically there's a little shorting cap that you put on there, so they're S1, 2, 3, 6 and 7. 1, 2, 3, 6 and 7. These are going to be a pain in the neck to solder, these are. Because you can't really hold them because they'll burn you. So, where are we? Where's S1 then? Come on. This is starting to get a bit busy now, this board. Okay, so the longest ones need to be pointing upwards. So how are we going to do this without... We can use a bit of blue tack maybe to just hold that. Let's do that. Bit of blue tack. Let's just pop a bit of blue tack on there. That's S1. S2. I'm overlapping S3 there. So I might be able to kill two birds with one stone and get both of those. Yeah. 2, 3. So I'm just blobbing little bits of blue tack. I've got a lump of blue tack, so I'm just using that to stick them down for a minute. Be careful because it can get everywhere, this blue tack. It can be a pain in the ass to get off. It's S1, 2, 3, S6 and 7, I think, wasn't it? So where was S7? I can't see S7. R7. Capacitors. Oh, it's right over here. Oh, I couldn't see it. Oh my god, I'm going to hold that one in there. I have to get a bit creative with the blue tack on that one. There we go. So they're all held in. So let's flip it over and get them soldered off up quick before they disappear. Now, where are they? There's one there. One there. One there. A sewing thimble. George! George is in. George is in the house. How you doing, George? There we are, all soldered up. So see if we can get the blue tack back off. One piece. There's always one, isn't there? There we are, that's all of our headers on, they all look pretty straight. Yep, good. Excellent. Milling chip 2. You usually use snips to cut those pins easier than a knife. Yeah, it could well have been. Benji, you 2 months worth to go. Yeah, I'd say I didn't really plan for it this year, but I will probably go next year. I'll get a good day out there, George. I don't think I've seen you there before, have I? Let's look over that. They all look good. Okay, next. What's next? It's getting a very busy board now. We've still got plenty of time, so we're doing all right for time. Let me see what is next. Okay, we've done the jumpers. Ceramic capacitors next. Oh, these are going to be fun. We've got a lot of capacitors going in now. A lot of capacitors. That's all this lot here. So ceramics first. These are a bit of a pain, but they should be marked. So what are these? K5M 104. These are all 104s. So there's loads of those in there. Okay. That's 104s. Little ceramics. These are normal ceramic. Then there's multi-layer. No, these are multi-layer ceramic apparently. It's all different values as well. What a pain. But you know, can't have it all easy, can we? Just tip these out and find them then. Let's get rid of the electrolytics for a minute. We'll put those over there to one side. I'm sure they'll be coming later. Various different makes. What's that one? Epcos. What are these? Lelon or Lelor? I don't know. Lelon, I think. Again, I don't think these need to be critical. Quite a lot of electrolytics actually. Right, okay, so we need to find first one that's marked 33. God, here it's tiny. I bet they're not marked either. No, they're not marked 33, are they? They wouldn't be, would they? I'll tell you what, hang on, 33J. 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 So we've got two 102s there. A 103, that's easy enough. God knows what that says. 5A 2213. 2213. I can't read that, one's too tiny. It's another 103. That's too tiny. Good God, I can't see that at all. I can't read that. Flipping heck, I'm going to have to go and get a high power magnifier for that. Oh, it's 561, 821, and 181. Okay. So we've got the two 33s, let's put them in first. That's C12 and C13, let's go with those two. How the hell are you supposed to read that? C12 and C13. C10, C11, C14. Where is it? Where is it? Well, I can't find C12 and C13. C10, C102, C11, C14, 15. Where is C12 and C13? C10, C11. I've got C102 and C103. I wonder if they've changed the board markings. I bet they blimmin' have. I bet they've changed the board markings. I can't see it anywhere. Catch you soon, George. Between R13 to R17 may be short from the above POV. Let's have a look at the board layout, because I think they've just changed the stencil on the board. C12 and 13 is... it's right there in front of my eyes. It's easier to actually see on the board layout picture. So C12 and C13, I found them. They're there, smack bang in the middle. They're right there. I don't know why I couldn't see those. C12. And C13. Extraction. I don't know why I did that really. I'm supposed to be putting all of these in first and soldering them up later, aren't I? Right, so 180 picofarad. That's marked as 181. That's got to be one of these tiny ones. 181J, that's that one there. That is in C30. Now I did see C30, that's over there. Let's go around that way so we can see the value. C30, so 220 is 221. 221. 221. That is C15. C17, 679, C14, come on, where? Ah, C15, there we are. away over by this switch bank. .221 is another 221 is C27. Is that one? C27. Down here. Hopefully you can see what I'm up to. C27, and there's an 820, 821 or a 560. Okay. So I've got to install the 820 if I'm using the supplied wire antenna for in-home precursor if using the external. So I need the 820, 821. That's that one. That's a C23. So I'm only going to be using the wire antenna that come with it. I'm not going to be broadcasting to the whole world. Tempting as it is. C22. C21, there we are. That's right in by that IC there. C17 is a 102. C17 is a 102 and C21 is a 102. Where's that gone? C21, 22. Hey, I've already got C21. Hang on. Why have I got that one in C21 then? Got one in wrong here. What is that one? That's actually in C23. Now I'm getting confused now. C23 that's got to go in, not C21. Ah, there we are, C23, that's better. Cracking up here. Why did I put C23 and C21? Okay, that's that one. So this one's now going in C21 or 102. Could have been, could have killed it dead, couldn't I? Well, I don't think it would kill it dead, but it would just probably make it unstable or put me on the wrong frequency. You never know. Rocco, how you doing, mate? Northern Rambler, Victor, how you doing, mate? Didn't see you drop in, Victor. Need one of those PCB rotisserie. It looks like Amazon has them, $30. Yeah, they're well worth it, Rocco. Not expensive. As I say, this was a gift from Mr. Andrew Ausfa. So C21 we've just done. C14 is a 103. That's that one. C14. Where's C14? Finding C14. It's good that you're following along with me, people. Have you got the schematic up, or are you just looking at it on my board? The C14. Let's do that the other way around so we can read it. Just in case we need to check later. How you doing, Victor? Anyway, I've not seen you on our chat group for a while. Hope you're okay, mate. And also another 103 or 0.01 microfarad in C16. In there. Okay, now all the rest of them are these 0.1. God, there's a lot of them. Look at this lot. That's a lot of capacitors to go in now. Theo, hello mate, how are you? Where's the goat? The goat's here. There he is. Nick, you've been to Stow-on-the-Wold to see a friend. Welcome, mate. The goat has battery issues. The goat's live. We sorted the goat last week. We fixed him up, didn't we? We tweaked his battery. Right, let's get all these in then. So C1, 2 and 3 first. These are all on this blimmin' stuff as well, which is a bit of a pain. C1. C2. A bit of extra blue tack there, I think. C2, are you going to go in? Yeah, going in. C2 and C3. C3, okay, next is C6. I see him. God, I'll tell you, this is a pain to get the sticky tape off of these. C6 is in there. C7. It's a lot of them. Yeah, I've heard from Sean, he's okay, mate. Hi, Rob. Rob Bond. Theakston lunch. Yeah, Sean is about, people. Don't worry about Sean, he'll be back. He will be back. Right, C7. But nice of you to ask after him. See 8, 9, 10 and 11 next then. Nice and easy. Eight. It's getting very busy underneath here now with component legs. Let's keep going, we're getting there. How am I doing, Les? Anyway, you built one of these yourself, haven't you? Am I doing okay? 8, 9, 10 and 11, I said, didn't I? I've got another kit over there, half built as well, 3/4 built actually. I must get around to finishing. That's my 2-tone oscillator kit. So I've got some old SSB CBs here that I want to try them out with. And I've also got that Yaesu 757 that needs, well, it doesn't need a trim up, but I'd like to do an alignment on it. It'd be nice to see if I could do it with that one. C1122 next, C22. Come in, C22, I see you, C22. Get in there, C28. God, there's a lot of components on this thing, isn't there? Right, what am I on? C22 or C28? I don't know, I've lost track now. I've got to keep concentrating on this really. C22, so it must be the next one. Got to be C28 then. C28, there we are. My God, there's a lot of capacitors on this. C31. It's in there. C100. I've got it. I'll tell you what, I've not got any fingernails left after scraping all this masking tape off. C100. There's a lot of soldering to do in a minute. 101, 102 and 103. There we are. That is all of the ceramics in. Oh, well, that was a lot of caps. That was a hell of a lot of caps. God, that was a massive amount of caps. I mean, look at all the legs on that lot to solder up that. Whew. How are we doing on the chat? Let's have a look. Yeah, Benji's selling out fast, people. Come and get it while you can. Right. Let's get this soldered up. I suppose Sean is watching Mr. Man Cave. Although I know he's got other stuff on Sundays at the moment, so probably why we haven't seen him for a while. Right. Well, I've still got this wrist strap on, probably don't need that on now, but... Can't even get the solder in here. So many legs sticking out. I think I've got them. Yep, got them. Derek! Thank you, mate. I'm number one. Excellent. Yeah, you're right, Derek. It would be a lot more. I mean, we've got 5 ICs on the board, so there's a lot of components, though, isn't it? It's nearly as much as that airband radio. Remember that one, Derek, that you sent me? That was a lot of components on that one. Let's cut all these legs off again as usual. A lot of legs. Get in there. Cool. There we go. Whoa, what a lot of legs. It's like an avalanche of legs now. Yeah, thanks very much, Derek, for the super chat, mate. Much appreciated. There's a lot of legs there. Oh. It's when you wake up with one of these stuck in your leg that you've got problems. I keep dropping them on my chair here. I'll slide forward on the chair. I want to go somewhere where it shouldn't be going. Right, okay. I need to just touch up some of these legs, so let's go back in and have a look. Not that they're too bad though, to be fair. Got a job to see where they are. There's one there, there's one there, one there. That's a lot of capacitors. You can sort of see roughly where they're going to be because they're decoupling all around the ICs. Yeah, I think that's got them all. Yep, all looking good. Right, okay, capacitor's done. What next then? Ceramic trimmer capacitor next. C5, 12 to 100 picofarads, 7mm ceramic trimmer. Well, where's that one then? I don't remember seeing that one in my packet of capacitors. Ah, there he is. 7mm ceramic trimmer. There we go. And that's in C5. Well, this is one of these little trimmer caps. Look, you can't see. Let's go on to that one. A lot of components on those chips. Looking good, floppy. Had chips for lunch. Right, where the hell does that go then? C5. Well, C5, wouldn't it? Yeah, C5. It's got to be up the top here somewhere then. C4. C5. Oh Christ, that's huge. over there. It's in there. So let's have a look. Are we going to be able to solder that one? We should be able to solder that one without it dropping out, hopefully. Let's tack that one first. Yep, got it. There we go, that's C5. In. I'm just going to quickly skip to the loo. Gonna have a quick comfort break a minute, so I'll be back. Talk amongst yourselves. Right, on my way back. Find out what we're going to put in this thing next. We're getting close, I think. We're well over halfway, I'm sure. So, ceramic trimmer caps in, rear panel jacks. All jacks must be seated squarely in place against the board before soldering to ensure proper alignment with the hose in the enclosure rear panel. The RCA jacks will snap into the board hose. You need to bend the 3 outer tabs slightly outwards from center to get the proper snap in action. Okay. Jacks. You like that, do you? I'm just a fuss ass, and but yeah. You're dead right. All the tolerance bands with the resistors and the inductors are all the same. Okay, that's the potentiometers. So we've got 3 RCA plugs. Floppy, you've got a solar power panel that powers a small radio to keep your budgie company. Excellent. Yeah, thanks, Victor. How's your workshop coming on anyway, Victor? Must be nearly done now. You must be on the home straight. Your shack come workshop. Okay, so rear panel jacks, J1 and J2 are RCA jacks. So they've got to be these here. Yeah, they are a little bit floppy, aren't they, Fred? A little bit floppy, so we need to bend them outwards apparently, but they've got to be nice and square, otherwise they won't make contact, or they won't line up with the holes in the, what's its name? Okay, yeah, they're going to be tricky. J1, 2 and 4, that's right, isn't it? J1, 2 and 4, yeah, okay. Oh. So J4 has got to be yellow, so I've got that the wrong way straight away. J4 is yellow insulator. Try again. Try again. Yeah, that's what I thought. If I keep them all the same way round, it makes it a lot easier to read them then. Right, J4 is yellow, so J1 is white. Now they tell me. Yellow is usually for video, isn't it? And red and white are left and right channel. But obviously there's no video on this. Oh, steady. So push that in now. So it's got to be, the last one has got to be red because that's all I've got left. So yeah, although they're snapping connectors, they're quite big for the holes. The holes are big, a bit big for the tabs really. So I think what we're going to have to do is just tack one of these, fiddle it around, and then so I'm going to tack the center pin on these first. Had a major delay during the summer with a guy laying the concrete floor. He's coming this Friday. Oh well, good luck. Good luck, Victor. Good luck, mate. Right, I don't need the goggles on for this bit, really, but let's take them off. I'm going to go and get a normal beer in a minute, I think. So what I think I'm going to do on this, I'm going to tack the center pin in first. On each of them. And that should give me, should hopefully be able to, well not tack, I'm going to solder them in properly and then I'm going to move them because they're not connected to the case. So that's it's nice and tight, this one. Tight. And this one. So I'm just checking to make sure they're square. They all look to be right. Okay, so I can go ahead and solder the rest in now. Just going to put a little bit of flux on each one again. You don't have to use flux, but it does help, as I said before. Get a decent joint on it. Let them cool down a minute because they're quite big pins on those. Make sure they're nice and flush to the board and square, which they all are. And solder's run through quite nice. We've got a bit of a blob there. Bit of a blobby bit there. Let's just get that with a soldering iron. Excellent. Yeah, all good. Brilliant. Right, that's the jack plugs in. Jacky plugs are in. Okay, how are we doing now then? Next, oh, power jack, J3. We'll put the power jack in. J3. Okay, so this one could potentially be a bit wonky. So so this one just here. So you need to make sure that pin there is square, I think. Let's pop a little bit of flux on that one. I'll stick the goggles back on now so I can see closer. That pretty much centralises it anyway by the looks of it, so according to the screen print it wants to go over a little bit, but power jack in, coming along. Variable resistors. So again, these have got to be square, so these are going in the back here. 34, 35 and 36. Are they all the same? No, 2 are 50k and 1 is 20k. Okay, so I need to make sure we get them in the right order. So R36 is the odd one out, and that is 20k, 50k, 20k, 50k. Right, okay, so that's R36 is the odd one out. So again, these have got to be pretty square. It looks like these snap into the holes a lot better. Yeah, they snap in nice actually. They're all perfectly aligned. Excellent. Let's look at them from a distance, just make 100% sure. Yep, all good. Right. Solder them 3 up then. Must be a good radio there. But saying that, I mean, radios don't normally go wrong unless they're fitted with AF117s. Well, radios don't, of course they go wrong. Right, going in. There we go. They're in. Potentiometers are in. Brew time, yeah. Right, next. Voltage regulator and transistors. Lead bending guide. Right, okay. All transistors and the plus 5 volt regulator all have the same TO92 package style. Please check part markings before insertion to get them all in the right places. Orientate each component to match a board outline, beginning the body of the component, bend the 2 out least, blah, 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 blah. Okay. So let's find these bits then. So what U4 is an L78L05. That's standard transistors. 78L05 is that one. Okay, so N3986 Q1. Okay, right. I'm with the program, I think. So this one's going in first. This is the 5 volt regulator. SMA L05, and that goes in U4. So U4, come in U4, U1, Q4, Q3, U4, there we are, U4 that way round. I'll just bend two of the legs, that'll hold that one in. So Q1, 2N3906, which is this one here, 3906, fairly standard transistor. In fact, all of these are standard, so 222, 2222. So Q1, that way round. And Q2, 3, 4, and 5 are all these 222s. 2. In fact, the flats are all the same way, really, so it's difficult to get them the wrong way round. Three. It's getting very busy in here now, isn't it? 3, where's the rest of them? You can't see if you're looking sometimes, can you? 4, 5. Right, transistors. I'm going to try and get them looking okay. It's difficult to solder transistors all in looking nice, mind you, but we'll give it a go. So I've just soldered one leg of each. So I'm just going to flip it and check them for squareness. So that one wants to come up a little bit. Just square these all up a little bit before I finally solder them. I know it's fussy in it, but you know, I can't help myself. There we go. Right, solder them up. There we go. That's all the transistors in, all looking nice and neat. Just trimming all the legs. Let's go back in and just have a quick touch up. To here. In, done. Whew. Thomas, thank you, Thomas. Massive queues at petrol stations still. So there we are, some more of a 3D view of it. It's looking pretty good, isn't it? We haven't got a lot left now. Electrolytics next then. This is the ones that we need to get in the right way round, don't we, Graham? Yes, Graham, you must get them the right way round. Not the wrong way as usual. Okay, so C18 first and 4.7 microfarads. So we've only got one 4.7 and all the rest are 10s. Oh no, most of them are 10s. So where's our 4.7? Is that the odd one out? That's that one there, okay, and that is in C18. C18 is... should be getting easier to find these now, surely, Graham. Come on, where's C18? There he is. Positive that way round. So it's marked on the board which is which, so that helps. So the rest are 10s. Take it, that's these. How many 10s have we got? 1, 2, 3, 4, 5 10s. See 20, 24, 25. See 20 in there, positive that way. (20) 24, 25, 26, 24, 25, 26. Let's hope the board's marked correctly. And C29 is the last one, which is in there. Oh, get in there. Stuck to my finger. Sticky fingers. C32 is 100. And the last one is a 470 C4. Right, let's get those soldered on. Dry as a packet of dry roast. Good old Shango. He does know his stuff though, doesn't he, Ralph? He's a very what's the word? He's a very clever chap. So just soldered one side of each of the caps up. We'll just check that they're all level. That one isn't. All good, let's get them soldered. One left, nearly missed one. We're getting close, half an hour. We've got time to get this finished in half an hour. Getting close. Right, just go to and touch these up again as usual. I can't see where I've been though, that's the thing. It's all in here then. And they're down. There we go. That's all the caps in. It's really looking pretty busy now, that. Next, RFI suppression coils. these are all the same, L1, L2 and L3. 3 large coils, that's these 3. They are lumpy actually, aren't they? They're all 1000 microhenries at 0.8 of an amp. So yeah, they're pretty lumpy, those. So a lot of these kits you've got to wind the coils yourself, but they've done it for us here, which is very nice of them. So let's have a look which way round is the right, and we'll get the right end on the outside of each of these. So well, that's got the right end on top. It doesn't look like these are in any particular order. They're not really going to be the same way around. I just want to make sure they're level with each other. And the last one has got to be L3, where's that one? 2, then L1 up there. There we go. Right, let's get them put in. Let's get them soldered on. Bit more heat on, we'll dwell the iron for a bit longer on these because they are quite thick legs, these. Just want to make sure the heat gets right into them. You can usually see the solder creeping up the leg of the component. Not too mad because they have got polythene covers. Let's have a look at those. Nice. And squirrels a bit on the drunk side. Let's have a look at that one. Straighten them up a bit. There we go. Let's chop the legs and we'll solder them. Give them a bit more solder. There we are, inductors are in. Next, quartz crystal. Okay, again, you've got to be careful soldering a crystal in. And that is good. Oh, there we go. I've got 2 different ones here. So we should have a 4 megahertz crystal. Or should it be 3.6? AMT 9309K. This said 9K on it, so this is the 9 kilohertz steps, I'll take it. So there's our crystal. and this is 3.6 mags. So that's going to be, it's going to be only be in one place, can it? Let's pop it in there. Can we see? Let's pop it around that way. Yeah, I can see it from there. So again, I'm not going to bend the legs on this one. Just going to tack it in place. Typical, innit? It won't tack. Crystals are a little bit fragile. They don't like a lot of heat, because you can actually cause a problem within the crystal with it with the actual crystal element inside coming desoldered. In and out on that one, nice and quick. Let's quickly touch that up. Done. It's not hot, ideal. 15-volt regulator and heat sink, so I need my little pack of bits and pieces now. Want a Seisho TV radio alarm to play with as a future video. Small colour one, seems a shame to throw it. That'd be interesting to have a look at, Rolf. He is very dry. He is very dry, Rolf. So there's our heat sink. I've got some hardware to go with this now. We've got heatsink mounting nut, heatsink mounting washer, and heatsink mounting screw to go with our voltage regulator. So I assume that's these. So do we need to put any compound on there? So it's got to basically go that way round, in there, washer on. It's a whacking great nut for this screw, really, but it's a huge great nut. In fact, the nut. Okay, it does. Let's just have a look at that, make sure it's square. Have we got a big enough nut driver for that? That's going to be just about do it. So screw that on a second. I don't suppose it matters too much, does it? There we go. It's on. Is it straight? Yeah, straight, okay. So, heat shrink notice here. Oh, it says to solder it first and then put this thing. Oh well, never mind. We've done it the other way round. says solder it first and then put the heatsink on last, but we've done it the other way around. One hour. Right, let's just tack this one in as well then. Stick some solder on the center one first. Make sure we're level. Which we are. Let's do the other two. Done. LED. LED, where are you? Down here. Right, okay, so we've got to get this one the right way around. Okay, so we've got to bend this a specific way. This is going to be fun. Okay, so we've got to specifically bend this. I need to make sure it's the right orientation as well. It's normally a flat which indicates which is the positive. Is it the longer legs are positive, isn't it, I believe? Hold the LED horizontally with the shorter cathode leg facing you. Bend both these downwards at a right angle at a point 5.3 mil. There's got to be 5.3 mil bend in this, so I've got to have it facing me like that. Hold the LED horizontally with a shorter lead facing you. Bend both leads downward at a right angle at a point of 5.31 mil. Well, that's literally right at the bend there, so it's right at the... Oh damn, I've done it the wrong way round, look. Flipping heck. Okay. I'll get this right, otherwise it won't line up with the hole in the front. That's the trouble. So we're on 6.5. So I'm weakening these legs every time I bend them. That's the trouble. Already bent them the wrong way once. Let's try again. Okay, this may be a fraction more. So that one the same. Okay, let's see that. That should hopefully be bang on. Yes, it is. Fraction under 5.5 mil. Set the leads into the board there with the longer lead on the arrow side and the shorter line on the lead side. On the negative side. And now it's got to be inserted 10.9 mil. Flipping heck. It's going to be 10.9 mil high. That's a bit exact, isn't it? Okay. Right, let's try that a minute. Let's try that. We're not going to have time to finish this today, I don't think, unfortunately. There's a bit of a... So I'm just going to solder one first. Check it for straightness. So it's not straight, it's wonky that way, so we need to bring it around a bit. Check that measurement again. Bang on. What a game. Oh, cheers, Rolf. You're back. Just a drum cleaning and adjustment. Other crystal. There's only one in there, isn't there? Have I missed something? Have I missed something? There's only one in there, isn't there? Yeah, there is only one crystal on it, Victor. Let me solder that one in. Got the legs of that one to snip off. Okay, LED. What next then? I think we've got to put the ICs in next. ICs are static sensitive. Discharge your body by touching the edge. Avoid shuffling your feet or sliding around on a chair while handling the ICs. ICs must be mounted in their sockets in one direction only. So it's time for the IC installation. Let's get on the overhead camera. The length of the LED legs change the properties? No, it's just so as it lines up with the front panel on the display. Sorry, not on the display, on the front of the transmitter. Let's get some of this stuff out of the way. I don't want to mess these up. So what's this one here? This is a SN74HC4060N. That goes in U2. Now these won't fit the sockets, but somewhere I've got the very nice leg bender that Derek let me have. And I wonder if I can find that. Let me just unclip my anti-static thing. I think it's in behind here. Or did I knock it on the floor? What have I done with that? I have seen that here recently. Can't find me leg bender. It's typical, isn't it? Typical. It was right here. Right here. Right now. It's been beamed up with all the other things that disappear off the bench here. That's a shame. I'll have to bend it by hand then. So I'm just going to do it on the bench, just going to give it a little tweak either side. And that's in a U2. So where is U2 is there. We've got to get it the right way around there. Make sure they're all lined up and not... U2 is in. Next one is a 40103 8-bit synchronous binary down counter 16-pin dip. U3. Good. Yeah, okay. Next one, 40103 again. U5. So when you get a brand new chip, it will not fit in a socket. You've just got to bend the legs a little tiny bit. So this is U5 1030, yeah. And the last one's got to be in there, isn't it? This is the PLO chip apparently. It's an HC4046 PLO phase lock loop. Could love phase lock loops, don't you? They're a pain in the back body when they go wrong. Right, let's pop that one in. Make sure they're all the right way round. No, it's got to go a bit more. There's always one, isn't there? Ah, I had it in then. Let's pop back out again. Get in there. Get in. Got him. Right, brill. Okay, that's that. That's our 4 ICs in. Then we've got to put our jumpers on. That's these little black things. And S1 in shorted position. So where's S1? There, in shorted position. S2 shorted. S3 shorted. S6 in open position. And S7 in open position. Well, where's the other, I've got a jumper missing, I think. Unless it's jumped off somewhere. Yeah, we've got a jumper missing. Doesn't matter because it's got to be open anyway. So it actually doesn't need a jumper on it, but it might. Hang on, there it is. There it is. Stuck to the sticky label. So that's got to be in the open position as well. There we are, that's the jumpers done. So I'm nearly there. I am literally nearly there, but I've got to call it a day there. That's really teasing, isn't it? So apologies for that. We've got just a bit of wiring up, and then it's going to be testing. Testing. Yeah, it's 6 o'clock, so that's pretty much my cue for end of the stream today. So next Sunday we'll be connecting up these wires. That's all that's left really, is these wires. Let's get that off my head. Ugh. I've got to wire up the plug. I'm going to see if I can find a power supply as well that will work with this. So it's got its own standalone power supply because I can't have it plugged into the thing all the time, the power supply. So I need to see if I can find or build an 18-volt power supply. So there we are, nearly, so near yet so far. There are small size and normal size version of jumpers like in PCs. Yeah, that's just sort of standard size jumpers really, that. So there you are, our finished, almost finished transmitter. Just noticed I've got a wonky, I've knocked that one, that's why. There we are. Thanks very much, Victor. What a marathon. If it's open, you won't need it. I know that, but I'm sure at some stage, Victor, they'll say you need to short that over to set something and then take it back off again, so. There we are, people. Sorry we haven't really got time to finish that completely, but it's probably still got another probably 45 minutes left in it yet. By the time I solder it all up and go and find a power supply and get it powered up and trim it and all the rest of it, there's a fair bit more left in the book. So we've got to attach the antenna and ground wires. We've got to then go over and visually check it, so I'll also need to get rid of all the flux on the back of the board. Then we've got to power it up. We've got to do the RF tuning then to set the frequency. It operates more efficiently at higher frequencies apparently. Then you've got to set the RF output tuning range. You've got to peak the RF output. Then you've got some audio adjustments to do. You've got to adjust the gain control, modulation control, and compression control. You've got audio adjustment procedure, board jumper options, a word about AC building wiring interference problems, jumper plugs, audio source. Yeah, there's a lot of stuff left to do on this here. Yeah, we've got a good hour or so left on this yet. We've got to stick it in the enclosure, don't forget. And then we've got to troubleshoot it and set it all up. It's a lot. There's probably a couple hours left in that yet, so we're only halfway through this book. So it's pretty much built. But next comes the hard bit of setting it all up. Yeah, I appreciate it. Right, let's just catch up with the chat then. So Nick is saying 4060 crystal oscillator and divider, if you remember rightly. Yeah. What do you think the IC is meant to do? I thought there was one for the 9 kilohertz steps and another for frequency generation. Bear in mind I'm late and haven't been paying attention. No worries, you're probably further up on it than me, Victor. But yes, it's for the 9 kilohertz steps, and we've got a PLL chip in there as well, so assuming that's doing some sort of generation. But saying that, that's probably the reference crystal, but it did say 9K on the packet, so imps. I do remember, I used to love those imps. Little tiny licorice monsters, weren't they? They were really strong. I did like that. Nice Tim. Thanks, Generation. Been good to watch, Floppy, yeah. Part 2 is coming. Cheers, Gavin. Yeah, power supply. Doug is saying the power supply is important, so we must... we definitely need a... I mean, end of the day, it's going to be a transformer, isn't it? Cheers, Les. So it's got to be a transformer, not a switch mode. And we'll be looking for an AC supply, not DC. Get her up slightly above medium wave with the Dutch pirates. Anything about the dip switches? Yeah, the dip switches are what controls the frequency generation. So you choose what frequency you want by setting the dip switches, and there's loads of settings in here. Look. So basically all the settings for the dip switches are on that page. So say I can set the frequency anywhere between 479 kilohertz and 2.523 megahertz. RF output tuning range. So yeah, so interesting to set that up. Best to build a well-filtered and regulated linear supply. I totally agree. What do I use to remove the flux? I'll just probably use IPA. I might use a flux cleaner actually, because this is a modern board, so flux cleaner, I'll get that off a lot quicker than IPA will. I do have some flue cleanse there, which is specifically for removing flux. Thanks, Arena. Dutch pirates. Thanks, Theo. No worries, Anthony. You take care as well, mate. What's the RF output? I'm not 100% sure. We know what the RF input is. It's 100 milliwatts, according to this. 100 milliwatts power input to final RF stage. And then Doug was saying it's likely to be around 60% efficient, if that, Doug, I think you said. So it's going to be less than that. So it's 100 milliwatt to the final stage. boost it up. Devon Community Pirate Radio. 100 milliwatts is the input to the final stage, Victor. You were way behind. You were looking at my soldering jig. Hi, Paddy. How you doing, mate? Yeah, no worries, Ralph. Cheers, mate. And I will catch up with your video with your battery buffers. So that's it for today, people. Thanks, everybody, for joining me. And thank you very much for the super chats from Derek and Rob. Thank you very much, people. Much appreciated, as always. And any comments, stick them in below. And if you're not a subscriber, hit that subscribe button. I'm going for 4,000 for Christmas, people. I'm about 3,800 now, so I need a couple hundred more to get me up to the magic 4,000 figure. It's magic for me because it's another milestone. I seem to do 1,000 every year, don't I? every Christmas I try and hit another milestone. So if you are watching and you're not a subscriber, hit that subscribe button and don't forget to click the bell, and you'll find out when I'm on next. And with that, I'll say goodbye to everybody and have a good week and see you next Sunday. Bye for now.